Our class today will be on normal distribution. Normal distribution. For all questions to do with normal distribution, you succinctly be told that it follows a normal distribution. And so before I teach you how to read these peculiar tables, I'll first of all take you through the properties of normal distribution. So a normal distributed distribution looks like this. It has about 5 properties of normal distribution. We have about 5 properties. Okay. Number 1, we can tell them by the way the distribution is looking. Can you tell me properties of normal distribution? From the shape, it is bell-shaped. All right, it is bell-shaped. What else can you see? It is asymmetrical. Bell-shaped it is asymmetrical. What does asymmetrical means? Meaning this side mirrors the other side. So if this is 50%, the other side is 50%. So it makes the area under graph to be what? 100%. It is also unimodal, meaning it has one single peak. So other distributions are multi, but this one is unimodal. It has one peak. All right. So we're basically looking at the characteristics of normal distribution before we get into explaining match. What other characteristics do we have for normal distribution? There are several. So I've spoken about symmetry, which means that both the probability density function is the same on both sides, meaning the left is the right side. It's unimodal. Then also the mean, mode, and median are all located at the center. Mean, mode, median are all at the center. They're equal and short. All right. What other characteristics do we have? It is a continuous distribution. So meaning it is continuous, which means that it can take any real value on a certain range. The tails extend indefinitely, means they don't touch the base. So like you can see here, they don't touch down there, they go infinite. So this is what you should know about normal distribution. So now we can now go to understanding how to read these distributions. So we read this distribution in a way such that if we have 1.23, we go here under 1.2 and 0.03 where they meet. That is a reading. So in this case, 1.23, what is the reading? 1.2 and 0.03. Where are they meeting? 0.8907. 0.8907. That is where they meet. So this is called the Z value. The probability of 1.23 is 0.8907. The opposite, I can go inside there. I ask you to give me the Z for the probability 0.8907. I just add 1.2 and 0.03. So what I get is 1.23. So this is a Z. All right. So sometimes you may not have the closest possible, or the immediate, for instance, I ask you, we are looking for the Z for 8750. This is 8749. You can still qualify it. So when you read, this is 1.15. That is the reading. So with that said, I want you to help me find the reading for 1.96, 1.67, and 2.0. Quickly, what is the reading for these ones? 1.96, what is the reading? 1.67 on 2.0.
One 1.96 is 0.9750.
1.96, 0.9750, correct. How about 1.67? Somebody else, 1.67. Mm-hmm.
0.9616.
0.9616. Okay. Are we together? Are we agreeable? How about the last one?
The last one was
Last one that is in there. 2.0.
0.9772.
0.9772. Correct. So this is when you're reading normally from outside to inside.
Sorry, Collins, could you please do 1.67 again?
So
Because I think from my understanding,
1.
I'm finding 0.9525.
Yes, 9525. We go under 1.6, 0.07 where they meet. We have 0.9525.
Yeah, not 0.9750.
Yes, this is the correct 9525. All right, now let's read from inside the table. You give me the reading for this 9495. What is the Z for this probability? 9525. What are we getting?
You mean 9 what? 9495.
Yes, 9495. The one I've underlined.
1.64.
1.64, correct. 1.64. All right. Now give me the reading for 0.8945. 8945. If you don't have the exact, you get the closest possible.
Oh, sorry, I was speaking and my mic was off. So we don't have 8955, did you say? But we've got 8944.
Yes.
Which is 1.25.
1.25, correct. So this is with regard to reading the tables. All right, so now we go to applying these tables. Any questions on reading the tables? Are you all clear? So it is very important to understand the concepts that I've just talked about, because these are needed everywhere we go with regards to this topic at hand. All right, so now I want to bring in a few principles in our grade 1. So remember, in our grade 1, Z is greater than 1.96. Greater means shade to the right. So 1.96, we are shading this direction here. And what can you tell me about this direction? It is a small direction. So the application of this is we subtract from 1 the probability that we're going to read from the table. Z can also be negative, 1.96. So this means that we are going to put on the left side of 0. And less means what? Shade left. So even this, since the shading is smaller than 50%, we are going to subtract. So far, we together, any questions? Sometimes you're not given the value of Z, you need to standardize it. We use the following formula for standardizing: X minus mu over standard deviation. If you're given a sample size, it's given by X minus mu, standard deviation over square root of n. All right, so now since we've learned how to read, I need you to help me find the values Z greater than 1.96, Z greater than 2, Z less than 1, Z less than negative 2.5, Z greater than negative 3.13. So we have A, B, C, D, E. So let's follow the principle called ISA. Illustrate, standardize, shade, and apply. So part A is asking us to find the probability of Z greater than 1.96. So first we illustrate based on the 0, since it's a Z we're using, unless it was X. Where's 1.96? 1.96 is here. Where we're going to shade, the sign tells us greater. So greater is to the right, less is to the left. So we're going to shade this small part here. So what is the reading from here up to here? 1.96. Let's go to our table. What is the reading for 1.96? What is the reading? 1.9, 2.06, so 0.9750. So this means that the reading from here to here is about 0.9750. 9750 or 97% from here to here. So how do we get the small shaded region? Remember what we said? We subtract 1 minus 0.9750. What do we get? One minus 750, we get 0.025. This could be about 2.5%. All right. Let's go. Z is greater than 2. Let's try. Who wants to lead us through? What do we do? Illustrate. So our 0 is in the middle. Where is the 2? The left or the right side of 0? Our 2 is on the right side of 0. So which part are we shading? The left side or the right side?
The right side.
The right side, correct. Why? Because greater.
Because greater is to the right. Less is to the left.
So we now check the reading for 2 in the table. Let's go to 2.0. What is the reading for 2? Zero 0.9772. So I mean the reading from here to here is 0.9772. So what is the remainder here? How do we get the remainder here? We subtract 1 minus 0.9772. So we get 0.0228. If they said Z is less than 2, would have read direct because this up to the starting point is already 97.72. All right, so who wants to help us try? How do we get there? Z is less than -2. What do we do? Illustrate. Our 0 is here, our -2 is on the left side. So if you're going to read the same Z, any values more than 50% are crossing the equal sign. So Z less than 2, which part are you looking at, the left or the right side? Less for the left side. So we'll start from 2. We're going to shade this part here. So when you go to the table, you just ignore the negative. Just look at the positive side. So 2.0 is 0.9772. So meaning that reading is coming from the other side. This is 0.9772. This is a reading from here up to there. So therefore, this small reading here, how do we get it? We subtract. So here we're going to get 0.0228. So sometimes you're not given the values of Z. You're actually given the values of X. So we're being asked, for instance, part A, find the probability that X is greater than 16. So using ISA, we first illustrate. So in this case, our mean is always in the middle. We know that mean standardized is the same as 0. Where is the 16? 16 is on the right side of 10. So we put our 16 here. So we have illustrated. Now we need to shade. We are shading because the sign says greater. We shade here. What does the shading tell you? Whenever the shading is small, we subtract from 1. The shading is big, we read direct. So the next one is to standardize. The formula for standardizing is X minus mean over standard deviation. So 16 minus 10 is 6 over 3, which is standard deviation, is 2. So this 16 standardized in terms of Z is a 2. So we read the 2 from inside the table. From the normal way, 2 is 0.9772. So this means that the shading from here to here is 0.9772. So what is the reading? We can say the reading of x greater than 16 is simply 1 minus 0.9772, which is 0.0228. Now, suppose we're told to find less than 13. So using ISA, illustrate. So our 10 is here, our 13 is there. We know that 10. So we need to standardize 13. How do you standardize the 13? X minus mu over standard deviation. So 13 minus 10 is 3. 3 over 3 is 1. So this one is there. We are shading on the left because it says what? Less than. This shading is big. So whenever it's big, we redirect, don't subtract. So let's go into the table under 1.0, we get 0.8413. So this reading here, 0.8413 is from here to here. So no need of subtracting. 8413, we redirect as it is. So this will be 0.8413. Now I want you to try. Suppose we're told to find x is less than 4. We are still using the same parameters. The mean is 10, the standard deviation is 3. Who wants to try? Step 1, what we do? Illustrate, correct? So what we put in the middle, 10 is equivalent to 0. Where do we put the 4? Based on the 10, is on the right, on the left side of 10.
The left.
Okay, then we are told less than, so we're shading to the left. So we standardize this 4. How do we standardize? X minus mu over standard deviation. So our x is 4 minus 10 over 3. So this is negative 6 over 3, which is negative 2. So this is negative 2. So since the shading is small, the rule is that whenever the shading is small, you subtract from what? From
1.
So let's read this 2 from the table. So when you go to the table, the 2 reading is at 0.9772. So this means from here, 0.9772. So to get the reading there, we are going to subtract from 1. So 0.0228. That is the shaded region here.
Mr. Collins,
Yes, sir.
yeah, although I joined a bit late, how are we treating the negative?
The negative just shows you that you're on the left side of the quadrant. So you can either ignore it or use a negative table, but I want you to concentrate on one table for now. And concentrate on one table for now. Yeah. So the negative just shows you that you're on the left side of that. Nothing else.
Is
Let's try
the
another.
class being recorded?
Yes, of course, all classes are recorded. Suppose you asked to find the probability of x is greater than 6. Let's use ISA to illustrate this. Illustrate, shade, standardize, and apply. So our mean is 10, our standard deviation is 3. Who wants to try to lead us? Illustrate, What is in the middle? 10. We know 10 is equivalent to 0. Okay, then let's locate where is the 6 based on the 10 on the left or on the right side of 10. Where's the 6?
On the left.
On the left side.
And where are we going to shade?
Shade between 6 and 10.
It says greater. So the mistake people will make is just to shade between there. But it's greater, even this side is greater. Shade until you shade normal. It's on the right side of 6. So this whole area here. Are we together? So we've illustrated and shaded. Now we need to standardize. How do you standardize? What's the form of standardizing? Z is equal to what? X minus what? Mu over standard deviation. Already you can see that the 6 is on the left side of the mean. So we're going to get a negative Z. So what is 6 minus 10 divided by 3? It's negative 4 over 3. So we're going to get negative 1.33. So the negative just shows that you're on the left side of Z. So let's read, what is the reading for negative 1.33? What is the reading for 1.33? You go on 1.3 and on 0.03 where they meet. So the reading will be what? 9066. So the big side should be 9066. So all these positive values that you're reading here are denoting the big side. So are we going to subtract or we read direct as it is?
We read direct as it is.
Yes, we read direct as it is. So 0.9066. All right, suppose we're asked to find the probability of X is less than 5. What are we going to do? Illustrate. The 10 is here, the 5 is there. We cut there. So which side are we shading?
Below 5, the small part.
Good. So this is a small part. So what are we going to do when we read? Are we going to subtract or read direct?
Need to subtract.
Subtract. Good. All small readings we subtract. So how do we standardize this 5? Z is equal to what? X minus mu over standard deviation. So 5 minus 10. Standard deviation was 3. So what is negative 5 over 3? 1.666. So you always leave to 2 decimal places. So negative 1.67. So mistake people will make be put 1.66. The nearest, you round it up here, 67. So let's read 1.67 in the table. What is the reading? We go under 1.6 and 0.07. 0.9525. So 0.9525. What you need to understand is that all the readings in the table are denoting the big part. So this 9525 is denoting the big part there. But we're not interested in the big part. We're interested in the small part. So how do we get the small part? By subtracting from 1. Are we following?
So, Mr. Collins, concerning the mean, the 10, is it always that you'll be given 10 or you have to use 10?
No. You'll be given different values. I'm just basing on the question that you were given there. You'll be given different values.
In terms of shading, when it's come to this, so you have to go by what you are given for the mean. if it's, for example, a given mean could be maybe 12, so meaning the middle part would be 12.
Yes, if you're given the mean as 12, yes. Yeah.
Also, the other thing I wanted to understand is when do numbers go on the right side? Like, for example, when does the 5 get to the right side of 10?
It's a number line. 5 will never be greater than 10 unless you're given 15.
So if it was 15, it was going to be on that other side.
Be on this other side.
Okay, so any number above the mode, mean, and median
Yes.
goes to the right. Then below it goes to the left. Okay.
Any other question?
I think just a request. I think once we are done, you can just send this recorded class so that you can go through. Some of us will join, I think when you had already started, so that you can catch up.
Not a problem. Okay, so let's try. I've sent you some questions on how they come. Let's try some of these questions so that we see the applicability. I hope you've seen the questions. Okay, so under normal distribution, we have the following questions. Let's be open-minded. Question number 1. We are asked to identify 3 characteristics of normal distribution. Who can answer? Number 1.
Bell-shaped.
Bell-shaped. Number 2.
Symmetrical,
Symmetrical, yes. Number 3.
mean, mode, median are located at the center.
Correct. Number 4.
Is I don't know the word, I've forgotten it. Sorry.
The tails don't touch the base, they're infinite. All right. So let's look at question number 2. Now you see that you're not always given what? 10. The speeds at which a car passes a checkpoint is normally distributed. The rev count is 60 miles per hour. Okay, then X is equal to 4 miles per hour. So let me look at the second one first of all. Question number 3. The selling prices of homes in a community follow a normal distribution with mean 276 and standard deviation 32. What's the probability that the next house will in the community will sell for more than 206? What's the probability that it will sell for less than 220? So now let's answer these questions before I proceed with intervals. So just a typing error there. This is mean and standard deviation. Okay, what are we given here? Can somebody extrapolate the data? What are we given there? The mean is what? 276. The standard deviation is what? 32. Part A, what is part A asking for? And the probability that the next house in the community will sell for more than 206. So what are they asking for? X is greater than what? 206. Can somebody help illustrate? What are we going to do? Using ISA, our mean, what would be in the middle here?
76.
276. And where is our 206 going to be?
Yes. Yeah, that is x is greater than
On the left side, because it's smaller using a number line. And where are we going to shade? On the right, because it says greater. So what does the shading tell you? Shading is big. So what are we going to do? We'll redirect. As simple as that. So let's standardize the 206. So how do you standardize the 206? 206 minus what? 276 divided by what? 32. What are we getting? $206 minus 276 divided by 32. We get negative 2 point. Round off to the nearest 2 decimal places. 19. So let's read in the table 2.19. What is the reading for 2.19? We'll go to our table. Make sure you know how to read the tables. That's the first thing I taught. 2.19. Tell me what's the reading for 2.19, Grace?
You said 0.29?
2.19.
0.19. 2.919 is 0.9857.
98.57.
Yes.
Which one is the 98.57? This small part or the Y part?
The bigger part, the wider part.
Which we are looking for. So in this case, are we going to
Mhm.
subtract from 1 or read it direct?
We'll read it directly because it's big.
Yes. All right. So the ladies have been represented. The gents now. What is the probability that the next house will sell for less than 220? So what are they? What's the notation? X is what?
Less. Oh, it's for the gents.
Yes. I'll help them. I think they can't manage.
no, not really. X is less than 220. Yes. Then the next step we need now to illustrate.
Okay.
Yeah. So we have the mean there, which is 276. And we are told that X is less 220. To start with, we know that 220 is less than 270, so it will be on the left side. Yeah, so X is less than 220, so we are shading the small part.
Excellent. Grace, the gents are also intelligent, eh? I thought it was only the ladies. So now, if the shading is small, even before we calculate it, what are we going to do? Are we going to redirect or we're going to subtract from 1?
We have to subtract.
Subtract from 1.
So how do we standardize the 220?
Yeah, we use the formula now. Yeah, so our mean there we have yeah, so we have got 220 there minus 276 over 32 to give us a negative. So this is 220 minus 276 to give us negative 56 over 32, which will give us negative 1.75.
Okay.
So
1.75.
we go on the table now. That is 1.7 and 0.005. So 1.7 there plus 0.05. So 0.5. 0.05. So what we have is 0.9599.
95.99. Okay, so this part is for the bigger part, right?
Yeah.
5.99. So how do we get this remaining one? We subtract, right?
Yeah.
Wow, interesting. So 1 minus 0.9599. All right, so let me continue teaching. So sometimes we'll be given percentages. Let me go back to my example. Suppose your mean is 10, the standard deviation is 3. We'll be asked find what? X, for which we are what? 2% greater. So since I taught you how to read from inside the table, they're tempting you to read from inside the table whenever you say percentage. So what is the value of X for which we're 2% greater? So you go to greater side is on the right side. So 2%, you cut it off. So what remains this side? 98%. So 98% is the same as 0.9 what? 800. So let's look for 98% from inside the table. 0.98. Get the closest possible. Let's check for 0.98 inside the table. Zero 0.98. The closest is somewhere 2.05. People would pick this one, but the closest is this one here. 0.9798. So what is the Z for this percentage? 2.05. All right. So meaning the Z for this part is 2.05. So we're looking for the value of X. So we know standardization formula is X minus mu over standard deviation. So our Z is 2.05. Our X we don't know. Our mean we know it's 10. Our standard deviation is 3. So you cross multiply. So 1 times that one, X minus 10 is equal to 3 times 2.05. X is equal to 10 plus 3 times 2.05. So what do we get? 3 times 2.05 plus 10 is equal to 16.15. So 16.15. That is the value of what? Of X.
Now, Mr. Collins, why did we get here? You said find X for, I don't know that number. What
So
is that number?
2% greater. So step 1, you remove the 2.1.
Sorry, you said find X for, I am not able to read it then.
For which we are 2.5% greater.
2.5.
2%.
Okay.
The value of X for which we are 2% greater. So whenever you're given a percentage,
Mhm.
you cut it off. So this 2%, we cut it off from there. So we remain with 98%, which is 0.98. Then you look for it from inside the table here, inside the table, look for 98% inside the table. So we're learning how to read. So like this one, 0.8907, this is a probability. Converted to Z, it's 1.2, 1.23. We also looked for numbers like 2.8945. We didn't have that, but we got the closest possible. It was under 1.25, which is 2.9844. We learned how to do that. Now here we're being asked to find 98%, 0.9800. So we look for 0.9800. In this case, we found ourselves closest to which one? 2.05. So we picked this one here, 0.9798. So this is as good as 98%. So we get 2.0 and 0.05. That is where the z is coming from, this 2.05. X, we don't know. Our mean is 10, our standard deviation is 3. We cross multiply. 1 times that is x minus 10. 3 times that is 6.15. When you add the 10, we get 16.15.
So the 2% is the one that, so where I was getting a bit confused is where to put the 2%, where you are differentiating the small part.
Yes. So also they ask us, find the value of x for which, find x for which we are, and 7.1% less. Okay. Given mean is what? The same 10. And standard deviation is what? 3. So being asked, find the value of x for which we are 7.1% less. The same principle, less meaning they're just tempting us to cut from the left side here. So when you cut 27.1%, what do we remain with this other side? When we subtract from 100, what do we remain with? 27.1.
Remain with 73.44.
73 point what?
44.
Are you sure? Subtract properly.
Let me do it. 100 minus 27.1. 72.9. 72.9.
72.9. All right. So we now check for this inside the table. 72.9 is the same as what? 0.729. So look for 0.729 what? 0.7290. So what are we getting? 7290. So is this 72.90 or 71.90? 1 minus 0.271. Yes, 7290. So look for it inside here. The closest is what? 7291. What is the reading for this? 7291?
0.61.
0.61, correct. So Z here is negative 0.61. Why are we using a negative? Because it's on the left side or on the left side. So using the standardization formula, our Z is negative 0.61. Our X, we don't know. Our mean is 10. Our standard deviation is what? 3. When you cross multiply, X minus 10, 3, negative 0.61. So X here, we're going to have 10 plus 3 is negative 0.61. So what do we have? $8.17.
It's according, there's 0.61. We are getting maybe on the table there.
Yes, 0.72. The 7290. The closest figure was 0.7291. So we read is 0.61. That's the reading for that 7290. It is equivalent to this. This is just a probability. We now need to convert it to Z. All right. So we will end here based on what I've taught. We'll continue on the intervals next class. I'll send you the recording and I'll send it down some exercise based on what I've just discussed. Any questions before?
Yeah, so maybe just a credit. I think